Welcome to the next video in the series. In the last couple of videos, we discussed some of the important operations that can be performed on the independent variable of your signal, that is the time. We discussed the three such operations. We discussed scaling, its physical significance. We discussed reflection, although reflection is a very simple operation, but it has some significance. Then we discussed shifting. Now, scaling and shifting are two important operations because these affect your signal, the waveform of your signal in one or the other way. We discussed that briefly last time in the last video. And another thing that we did here, that we consider these operations in isolation, right? Means when I discuss scaling, I took an original signal, we only performed scaling operation. Similarly, when we discuss shifting, we took a signal, we only performed the shift operation. But what happens that if both the operations coexist, that I have a signal, it is time scaled as well as time shifted. So something like this kind of a thing, that I have a signal y of t, which has been obtained from x of t by performing scaling by a factor a and shifting by a factor b. So here a is the scaling factor, time scaling factor to be more specific, and b is the shifting factor, the amount of shift. Fine. So for this we have a precedence rule. Fine. That is to get y of t from x of t after scaling by a factor a and time shifted by a factor b, there is a particular precedence rule. Right? So to correctly obtain y of t from x of t, as sometimes we say to faithfully obtain y of t from x of t, these two operations, shifting and scaling, they have to be performed in the correct order. So the correct order is that first we always perform what we call the shifting operation. Fine. So to obtain this from x of t, we will be first performing the shifting operation. So I will define an intermediate signal v of t, which is actually the shifted version of my original signal. So it is x of t minus b. Right? So first we perform time shifting by factor b, right, to get an intermediate signal v of t. Then once we are done with the time shifting, then we perform scaling. So the second step is y of t is equivalent to v of at, which essentially means x of at minus b, because scaling and shifting, they only apply what you call to the time variable, to the independent variable, to the time parameter. So this is the correct order. This was little bit that was left from the video, that when we perform two time independent the operations that are performed on the time variable, when they are simultaneously performed, that is, you have an original signal x of t, you have been given a scaling factor, you have been given a shifting factor, you have to follow a precedence rule. So the precedence rule is you will first get an intermediate signal, which is obtained by performing time shifting. Like in this case, we will first perform time shifting on the original signal x by a factor b. Then the second step is that you perform time scaling on this time shift signal. Fine. So v of t, x of at minus b. So this completes our basic operations on the signal. Before I can upload further videos, we will be doing a detailed online tutorial session wherein I will first of all answer if you have any queries regarding these operations and regarding the classification that we did, and then we will do a detailed tutorial session. We'll try to solve some numericals wherein we will be using this precedence rule for time shifting and scaling. Right? So next we will be seeing each other. Here we'll be actually virtually interacting for in the real time for the tutorial session and a doubt clearing session.